In this tutorial we're going to look at doing event-related averaging. Event-related averaging is useful if we want to visualize and compare the effects of different experimental conditions. So following on from the previous tutorial, we have a region of interest selected in the right hemisphere in slide 6. We can go into analysis and click on event-related averaging. We're presented with this window here. So we want to click on our experimental conditions. Fixation is our baseline, so we'll start with images in the left visual field. If we click on each in turn, you can see them plotted in the expected response plot window. However, only half of the plot is shown. We want to show the whole plot. We can show the whole plot by changing the pre and post values. These define the number of time points before and after the onset of the stimulus. If we change the post value to 24, we can now see the entire plot. We can now click on Create AVG, and we want to save this as CG Objects 1. Now it doesn't look like anything has happened. However, if we click on our time course window, and in the bottom left we can browse to the file we just saved. We now have a new window describing our event-related averaging plots for our region of interest. If we want to save this plot, we can right-click and choose Save. We can also change how the plot is displayed by clicking on Show Options dialog. We can choose the horizontal arrangement. We can also choose to hide the error bars and enable some title. What's useful about this is we can define new regions of interest. In doing so, we'll change our event-related averaging plots. In our current plot, the x-axis is in volumes. It may be appropriate to change your x-axis to time, representing our TR, which in this case is 2. To do this, we need to go back to Analysis and Event-Related Averaging, and click on our 3 predictors again. Where it says Resolution of Data Points, we want to change it from volumes to seconds. This will change our expected response plot, so to show this properly we need to change our post value to 54 and our pre value to 4. We also want to adjust the average form value in the percent signal change field to -4. Together with the average 2 value of 0, these parameters will define the mean signal intensity of the 4 seconds before the beginning of every event that are used as the baseline for computing the percentage of the signal change values. When prompted, we'll save this as CG Objects 2, and if we go back to our signal time course window, we can browse to the file we just saved, and in the new plot our x-axis will be in time. So this concludes the tutorial on event-related averaging, and also concludes part 1 of analysis in original space. In part 2 we'll look at analysis in standard 3D space.